Have you ever looked at a massive Lego castle and realized it's all made from the same few types of tiny bricks? No matter how complex the structure, the bricks are the same. In the world of mathematics, numbers work exactly the same way. Every big, composite number you see is actually a castle built from smaller, unbreakable blocks called prime numbers. Today, we're going to look at the blueprint of numbers, the fundamental theorem of arithmetic. It sounds fancy, but it's the secret code that holds all of math together. Hey everyone! Welcome back. If you're in CBSE Class 10, you've probably seen the term Fundamental Theorem of Arithmetic in Chapter 1. Most students skim past it, but this theorem is the reason why LCM and HCF exist, and why prime factorization is so important. By the end of this video, you won't just know the definition, you'll understand why this theorem is the DNA of every number. Before we hit the definition, let's refresh. Prime numbers are the loners. They only have two factors, 1 and themselves. Think of them as pure numbers, for example 2, 3, 5, 7, 11, 13, 17, are prime numbers. Composite numbers are the social ones, they are products of prime numbers that they can be broken down further into more than two factors. For example 4, 6, 8, 24, 274, are composite numbers. Here we have to note one thing, every number other than 1 is either prime or composite. If a given number is composite, then it can be written as a product of its two factors. These two factors in turn can also be either prime or composite. If composite, the factors can be split up further. If we keep on doing this factorization, finally we will arrive at a stage when all the factors are prime numbers as shown here. For the positive integer 1260. 1260 equals 2 by 630. Product of a prime and a composite number is equal to 2 times 2 times 315. Product of two primes and one composite number equals 2 times 2 times 3 times 105. Product of three primes and a composite number equals 2 times 2 times 3 times 3 times 35. Product of four primes and a composite number equals 2 times 2 times 3 times 3 times 5 times 7. Product of all prime numbers. This result can also be written as 1260 equals 2x 3x 5x 2x 7x 3. That is in other order. What do we observe here? We observe that in both results, the prime numbers appearing are the same even after changing their order in the factorization. Thus the factorization of 1260 is unique except for the order in which they appear. Let us now take another example. 1155 equals 3x 5x 7x 11, or 1155 equals 5x 11x 7x 3. We observe that the above observation is also true for 1155. This leads us to a conclusion that every number is either prime or the product of primes. This conclusion or result which we obtained just now is called the Fundamental Theorem of Arithmetic. And the development of number theory. This theorem is very important and is stated as given here. Every composite number can be expressed as a product of its primes, and this factorization is unique except for the order in which the prime factors occur. If n is a number, p1, p2, p3 are its prime factors and a1, a2, a3 are the powers of the prime numbers consequently, then n equals to p1, a1 multiplied by p2, a2 multiplied by p3, a3. Here the heavy word, unique, means there is only one set of primes for any number. For example, the DNA of 60 is 2, 2, 3, 5. No other number in the universe has that exact same DNA. Except from the order, means 2 times 3 times 5 is the same as 5 by 3 by 2. The sequence doesn't change the identity. This theorem has many significant applications in mathematics and in other fields. In mathematics it is used. A. To find the HCF and LCM of two positive integers. B. To prove the irrationality of irrational numbers. In cryptography it is used like passwords and online security. Now let us solve some problems to understand the theorem fully. Question 1. Express 3825 as a product of its primes. Step-by-step solution. Check divisibility by 2, the last digit is 5, odd, so it is not divisible by 2. Check divisibility by 3, sum of digits, 3 plus 8 plus 2 plus 5 is equal to 18. Since 18 is divisible by 3, the number is divisible by 3. 3825 divided by 3 equals 1275. Check 1275 for divisibility by 3, sum of digits, 1 plus 2 plus 7 plus 5 equals 15. Since 15 is divisible by 3, we divide again. 1275 divided by 3 equals 425. Check 425 for divisibility by 3, sum of digits, 4 plus 2 plus 5 equals 11. 11 is not divisible by 3, we move to the next prime, 5. Since it ends in 5, it is divisible by 5. 425 divided by 5 equals 85. Check 85 for divisibility by 5, 85 divided by 5 equals 17. Check 17 for divisibility, 17 is a prime number. It can only be divided by 17. 17 divided by 17 equals 1. Final representation. The prime factors are 3, 3, 5, 5, 17. Mathematical form, 3825 equals 3 times 3 times 5 times 5 times 17 or 3825 equals 3 raised to 2 multiplied by 5 raised to 2 multiplied by 17. Note: for finding prime factors of a number, always use the divisibility rules as your guide. If the sum of the digits is a multiple of 3, go with 3. If it ends in 5, go with 5. This systematic approach ensures you don't miss any factors and confirms the fundamental theorem of arithmetic, showing that this specific DNA of primes belongs only to the number 3825. Question: explain 3 by 5 by 7 plus 7 is a composite number. Please give solution with explanation. Step-by-step solution for this question is given here and is self-explanatory. Question 3. Show that 12 raised to n cannot end with 0 or 5 for any natural number n. Step-by-step solution. 12 equals 2 multiplied by 2 multiplied by 3. Or 12 equals 2 raised to 2 multiplied by 3. So, 12 raised to n equals 2 raised to 2n multiplied by 3 raised to n. Here we observe that the prime factorization of 12 raised to n contains only the prime factors 2 and 3. And according to the fundamental theorem of arithmetic, this product is unique. For any number to end with 0, its prime factorization must contain 2 and 5 as factors because 2 multiplied by 5 equals 10. In our case 2 is present but 5 is absent. Hence it can never end with 0. Here is question number 4 with its solution, which is self-explanatory. And here is a HOTS question number 5 with its step-wise solution, which is important from an examination point of view. In this video we have tried to make you get accustomed to all type of questions that may be asked in exams. If you want more questions on this topic, then you can find them in our Telegram channel. Link is given in the description of the video. So, to summarize, every composite number is built from unique prime blocks. This factorization is one of a kind that is unique. If this made the fundamental theorem of arithmetic click for you, hit that like button. It really helps the channel. Now, here's a challenging question for you. Solve it and drop your answer in the comments below, and I'll heart the correct ones. Don't forget to subscribe for the next topic, revisiting irrational numbers. See you in the next one.